Okay, welcome back. In the last video we were talking about tools for lower horsepower machines. So there's lots of really nice cutting tools out there, but many of them require a very, very rigid machine to perform properly. So over the years I've found some tools that I find very efficient for some of these lower horsepower machines, Bridgeport type machines, where we're limited to shanks less than an inch in diameter and limited horsepower and just kind of limited rigidity overall. And we still got to take metal off and do it efficiently, so finding a compromise of tools that you can work fast with and remove material and get it out of your way. So the one I'm going to show you now is it's a high-speed tool. Actually Cobalt, M42 Cobalt, and it's a roughing end mill, and this is what, 5 flute. This is 1 inch diameter, 3/4 shank, M42 Cobalt. It's made by YG, which is a Korean company, I believe. Anyway, they're fine pitch, and these are extremely efficient metal removal tools, and we'll see that here in a minute. I got some steel that I'm going to plow a pretty good groove through kind of in one shot. This is a demo. Anyway, I've been using these for years. They're relatively cheap, they last a long time, and typically you can get them, they got plenty of length of cut here, and what I've done in the past is, the end gets chowdered up, and we just shorten them up. We send them to the sharpening outfit, and they shorten them up and redo the ends. So anyway, this is a brand new one here. The only negative part about the corn cob or roughing end mill is it leaves a line finish on your work. Sometimes this is okay, and sometimes it's not okay. But this certainly works for getting that material out of your way, and then making your finishing tool do a lot less work to get there. Anyway, we're going to show that in a minute, and we're going to cut a groove. Okay, so here's one of these YG fine pitch roughers. This one's actually it's a regrind. So it's already had one regrind, so this thing's had plenty of life through it. 1 inch diameter, and so I want to cut a groove through this steel block. This is 4140 here, I believe. Or certainly behaving like that. And I'm going to cut about 350 deep in a single pass going across here. 200 RPM. And we're just using a little soluble oil. See that's just walking right through there. The feed pressure on the handle is actually pretty low. And it just went into the hole in the center there. Alright, there it's engaged with the other side now. I'm just using this to get the main part of the slot in here that I want. Then I'll go back with a finishing tool. Well, it gives you some idea of what you can do with one of these guys here. We said, these cut pretty good, and it leaves that little linear finish on there. The side's kind of bumpy, but that's okay. I'm going to go back and clean that up with a finishing tool. And this one's been around the block here. It's had some mileage on it, so a nice fresh one would really do pretty good. Okay, so we're back. We're working on the heavy-duty steady rest for the YAM lathe, and today we're going to work on these are the roller supports. This is a roller type steady rest, and it's going to use some bearing rollers. These are cam followers here. What we're making is this guy here. I don't know if you can see that. Anyway, this is this roller supports. There's two of them that are sandwiched like this, and then these will move out on center line to support the shafting that we have to turn. So anyway, I got a drawing. I'm going to get set up here, and we'll do some milling on these things. Initially, there's some work here on the, let's see if you can see that. There's some work here on this radius. I want to do a little bit of layout work here that will save me some trouble later on. So we'll just set up and do that part first on all of them, and it's pretty easy. So put that in there, something like that. Get my stop. So I'm just setting a length stop here, so I can just repeat everything really easily. And I'm not really trying to get it butted against there, because what I'm going to do, I'm going to lock all that down. I'm going to re-release this and then bring it up against the stop. It's too hard to get that dead nut against the end there. All right, so. We get a chuck in there. I got a power drawbar on my wish list here, but I got more important things to buy right now, so we do it the old-fashioned way. Now this edge finder that I'm using here is it's called the Super Jump, and I've been using these for years. They're more expensive than your run-of-the-mill ones, but I find that they are extremely sensitive and repeatable. So I've kind of just been using them for quite a while now. Let's see, SPI I think sells them, and let's see who else. I can't think of the name of that other outfit. I'll look it up. Standard edge finder stuff. Like I said, this is a nice edge finder because it jumps a long ways, and it's got a very broad lapped contact surface here. So it's 3/8 shank, the head's about a half inch or a little bigger, and then the standard 200 thousandths tip. It's called the Super Jump. Anyway, if you get a chance to try one, I highly recommend them. So. Okay, so we're kind of zeroed now. I want to zero the absolute now, just so I can have two zeros. Okay, so absolute. All right, let's look at the drawing. So I'm going to make a couple of marks just to start with. Basically, I'm using the mill as a layout tool here just to save me some trouble. All right, so there's 6 inches. So all I want is a little scribe line on either side, and this is just a carbide, a broken carbide end mill that is now just a pointer. One end of these I've already milled, so like that. You know, I could do this on the surface plate with the height gauge, but I just figured I'd do it this way. You know, your milling machine is you know, a coordinate measuring machine also, so you know, you can do layout on it too if you want. Just sometimes if you're already set up, it's just a handy way to do that. So there's 6 of these. There's 2 for each roller because I decided to sandwich the cam follower to support it better. I saw a lathe that had a really nice steady rest, Cazeneuve French lathe, and had a very, very nice steady rest that I like the look of. So I'm kind of copying that a little bit. So. Alright, so now we're just putting a little prick punch right there, and what we're going to do with that is we're going to scribe a little arc. We're going to scribe a little arc right there, and it's for 400 thousandths radius. No, that's not very ergonomic. I'm describing that radius. That's just going to guide my when I bandsaw the excess off of there. Actually, let's just do that. This will be easier. Hanging out, summertime, good time. Great song there. And these are my little little tiny Starrett Toolmakers dividers. I love these things. They get into these tight little spaces and they got nice sharp little tips. So ultimately what's going to happen here is that first scribe line that I did, I'm going to draw a line tangent like that. I'll bandsaw off most of that, then I'll mill that so that it's nice. And do that on both sides. And that's what will happen there. Okay, so now I can go ahead and poke the holes and get the centers put in there. 1.6, 1.5. All right. So I'm just using a stub drill here. They're nice and stiff, and it saves me Saves me a center drilling operation. Let's let it get started good. Alright, so got them all drilled now. I'm going to go ahead and ream them while I'm here. So
check out the Samsung Experience Shop at Best Buy near you. We're Californians. We have better things to do than spend our time and money on gas. Ford is the right choice for California. It achieves an EPA estimated rating of 47 city, 47
let's do this.
with 30% off everything in the store. This Friday and Saturday, 30% off brand new styles including dresses, shorts, polos, and more for the whole family. Hurry into Old Navy for 30% off the entire store and head out to summer. Valid May 31st to June 1st. Exclusive clearance items and gift cards. Right now at the Home Depot, an exclusive Husky 33-piece mechanics tool set is a special buy. Just $39.88. Ratchets, sockets, and bits you can count on forever. Because that's how long they're guaranteed to last. Having the right tool for the job.
Come on, you bugger.
Starts with a Husky $39.88. More savings. That's the power of the Home Depot. Supplies last U.S. only. Looking for a way to get your morning started? Head down to your local Chevron Extra Mile for a great deal on Seattle's best coffee and Red Bull 4-packs. Chevron Extra Mile. Extra easy. Extra value.
That's better.
Chevron locations.
Do that one? Okay, so I got more stuff to do on these in here. There's a little relief hole I'm going to go ahead and put in right now. Alright, so it's 7/8 back. Alright in there. So all this is just a little relief hole, because there's a clamp, there's a split and a clamp that clamp the little axle. So all that is just a relief hole to saw into. All right, this setup we're just pre-drilling the ends of the slots here. I like to just put a hole at either end that's a little smaller than the slot. It just helps me define what the length of the slot visually, and it gives me a nice starting hole. So what I always do is just make a little mark to start with and just scale it, just to make sure I'm not making any boo-boos, you know, with offsets or edge finder. I forgot to add the edge finder in or something like that. So it saved me many times that habit of just checking it with the scale, make sure you're there. All right, so we're using a roughing end mill to rough out this slot, clear this material out of the way, and then we'll finish it with a different end mill. One of those fine pitch, actually this isn't a fine pitch, this is a regular pitch, cobalt end mill, and the depth of cut here is the full 1/2 inch of the flat bar. Okay, Lathe slot. And you can see that that tool now. All right, we'll switch over to a finishing end mill now. I want the slot a little wider than the fastener size, so we'll go in here with this tool here, and this is just a regrind 3 flute carbide. I'm just taking a pass off either side to open the slot up slightly so that the fastener fits through there nicely. It's just a 1/2 inch fastener, but I just want a little bit of clearance there. And I'll go back and do the opposite side. Oop, do a little more. Yep. Okay, that's it. All right, so we're cutting a little groove in the end here. It's just a relief to clear another component, the push-pull mechanism that moves the roller guide back and forth. So anyway, we're just going to plow a little groove in there and make a relief. Push off. Oop. Back. Alright. Let me move that camera a little bit. Okay. Alright. So this is a 3/8 carbide end mill here, 3 flute. And just a little bit of oil on it. Running it, I don't know, 1200 RPM, something like that. It's a 100,000th depth to cut here. Those trips. Groove finishes up a little over about 220 deep. Alright, now I'm going to move sideways. I've already worked out my numbers, so okay, so now I'm going to go to my finished depth and my finished sidewall. There. So this is supposed to be 1/4 of an inch thick. 249, good, close enough. This is supposed to be 1/2 inch wide. 498. Okay, that's fine. We'll deburr that. Now this file has a safe edge on it. Alright, so that's the little relief groove, and the part that fits in there, it's just clearance for this thing in this area here. Not supposed to fit tight, it's just clearance, and it clears out the screw head on that collar. So what I want to do is I want to lay these out so I can cut this little angle on here. So it's gonna go straight, go into an angle, and then go into a radius, another angle. So it's just to give the more clearance around the end of the support. So I marked one of them just with a scriber and a ruler, and I measured the angle, and it's really close to 10 degrees, so I'm just going to make it 10 degrees. In the interest of fun, we'll go ahead and use a sine bar to set this up here, and then we'll use a height gauge to scribe that multiple times on the different parts instead of instead of just using a ruler. It's kind of funner, and you get to see a sine bar. I have a bunch of them. I picked this particular one, and what is this? Omer Roberts. It's kind of a nice one. It's 5 inches center to center, and it's about, I don't know, 5/8 of an inch thick. So it fits in the vise nice. It's not too tall, so it fits in a Kurt vise real good. Excuse me. You know, real simple deal here. These are, you shouldn't, you know, everybody should have one of these because it's a really easy way to set up angles. And they're deadly accurate, and real simple to use. So don't think of them as too accurate for your angle work. It's, you know, it's not out of hand to use one of these for this kind of stuff. So anyway, we got our 10 degrees. We want to bring this up to 10 degrees like that. So we got to do a quick little calculation. So we're going to take the, and it's called a sine bar for a reason. So we're going to take 10 degrees, and we'll take the sine of that, okay, which is 0.1736, and then we're going to multiply that by the length of the bar, which is 5. So we get 8682. Now, if we really wanted to set this up super accurate, we would use a stack of gauge blocks under this end. But what I like to use for quickies and not super fussy accuracy is these adjustable parallels. So I'm just gonna, what was my number? 868. So I just hold the calipers on there, and then I slide this with my fingers very carefully. Oops, 869, 870. Okay, 868. Okay, and then I'll just go ahead and just gently lock the screw. They typically they don't move, but you know, screws there. 868. Okay. All right, so we got our excuse me, our block. And we're just going to put it up against this here, just to keep everything kind of square with the world. All right, so that should be about 10 degrees. I might pull that out a little bit. And we'll put this up there just to see. And it looks pretty. It looks aligned with that line. So I'm going to get in there a little closer with my magnifier and line that up a little better. So I'm just going to, so I can do a repeat operation here, I'm just going to make the end of this. Actually, you know what? I should do the other end. This end isn't machined, so I'm going to go ahead and do this end. I'm going to flush up this end here so that when I pop these up here, they'll all land in the same place. So let's back this whole mess up like that. Yeah, that'll work. Okay, let me get my magnifier. All right, so let's get that lined up. Try not to block the camera. That looks pretty good. All right, so I'm just gonna make this flush with this end. Just gonna hold it in place. And all I need is a light scribe line on that, and I'm just gonna flip it over and line that edge up again. Now, a smart guy would have probably put some Dicom on there, but I'll be able to see this line. Yeah, that's no problem. You can see that pretty easily. So. And one of the old guys I work with really encouraged me to use the sine bar just because it was so accurate and just so simple. You know, why not use it, right? As it turns out, he died, and I ended up with his sine bar, his personal sine bar. I'll show you guys that in a minute here because it's kind of a neat one, and there's a little story that goes with it. Anyway, it's just kind of a handy thing. Anyway, he taught me the advantages of it and just the simplicity of it. You know, you can set a sine bar up about 5 times as fast as you can tip the head on the mill and get that reasonably accurate and get the job done. I'm just gonna bandsaw these. I'm gonna bandsaw the angles just to rough them out. Then I'll mill them so they're nice. I can't see that. Okay, last one. Okay. All right, so we're just going to go ahead and bandsaw that excess off of there, just so we don't have to mill so much. bandsaw, then we'll round that. Actually, I might end up belt sanding those just because I can cut them pretty close to the line. So anyway, got a few more to do. Okay, so I decided to go ahead and mill these angles instead of belt sanding them. It's just I don't know, you could go either way with that. I just decided to mill them, mainly because this is kind of maybe it's a good setup to view on video. So these holes have been reamed through these, so I'm just gonna stack them all together and mill them at once. So just to save some time. We'll slide all these together, and that references the one end to itself, or to each other, I should say. So we got that. Now you see they're all splayed out, but what we'll do is we'll just set them like that in here, and now those are all nicely lined up. So if I open up a cant twist here, put that in there. And I'm going to sandwich that whole mess together. Okay, so basically it's a solid piece of material now. I happen to have two 5-degree little wedges that I had made for something. I don't remember what they were. I saved them and I marked them at least. So I'm just going to stack those together, and those will be my angle reference in here. What I want though is I want this pin to be sitting on the vise like that, and then I'll move this up and down until I, get what I want. Magnifiers. Out there somewhere. Pretty good. Okay, so I got that sandwiched in there pretty good. And I got my Ceratip cutter here. Ceratip cutter with a chipped insert, so I'm going to change that insert. When I banged it the other day, so maybe that's what happened when I banged it. So. Yeah, the other ones look fine. Okay, so we're just going to deck this off now. Smooth as silk. I'm just going to come in the same direction just so the chips shoot off to the back. Yeah, that was quicker than belt sanding, so. And I'm just kissing the edge of that circle, so I'm done. Pretty nice finish, looking good. Looks pretty good to me. So, if it's down on that, if that's touching, the height should be the same if the angle's the same. So, I'm going to zero that. I'll back this up just a little bit, 10 thousandths or so. I'm going to look here because I can see my circle there. Oh yeah, we're good. There's nothing fussy about this angle. The only thing with angles when you're machining them is if you're off a little bit, a lot of times things don't match up. So you got to be a little bit careful when you're doing angular work, because when you have small angles and tapering and you have lines that are coming off edges and stuff, it's really easy to get them misaligned if you don't have your angles set accurately. Yeah, that was faster than belt sanding. Okay, so let's see how we did. Let me get a square. Okay, so you can see this line coming across here, right? If I line up with that here, and then I come across to the other side, you can see I don't know, 30,000, 40 thousandths off. Which one would want to come down? Well, this one would have to come down, yeah. For this project, I'm not going to worry about it. I'm just going to belt sand that radius on the end and call it good. Anyway, but you can see that if we set that up at a sign plate real accurately, we probably would have been better. But in this case, we have a small misalignment there at this low angle. Okay. Anyway. All right. We're gonna belt sand this little radius on the end of these things here. I thought I'd show you guys this thing here. This is a belt sander that I built, I don't know, about 20 years ago, something like that. It's a 6x48 belt and 5 horsepower. Why 5 horsepower? That's the motor I had. So the pulley is directly coupled to the motor, and then it has both rolls are crowned. This is the tracking mechanism here, and the belt tensioning device here. So this is tracking. This tips this pulley this way to get the belt to track, and then this is belt tension here. It's got a little dovetail slide that I made. Then it has you can change the angle of the table, and then you can move the table in and out to keep this gap nice and tight here. But anyway, we're just gonna belt sand this radius real quick on each one of these, and I wanted to show you the belt sander. So let's see. We're all right. Put some hearing protection on. Okay, a few more to go.